As the foundational part of the proposed architecture, Contoso decided to implement a GitHub Enterprise Cloud organization. This will allow for integration with Microsoft Azure Active Directory, or Azure AD, including support for single sign-on, or SSO, and passwordless authentication. To start your overview, let's examine how such integration is configured. To check the passwordless authentication options, in the Azure portal, navigate to the Azure AD page. From there to Security section and to Authentication Methods. On the Policies page, you can determine whether passwordless authentication methods, such as FIDO2 or Microsoft Authenticator, have been enabled. You can also identify the target groups or users. Next, let's examine the GitHub integration. From the Azure AD page, select Enterprise Applications. In the list of Enterprise Applications, locate the entry for GitHub Enterprise Cloud Organization. Once you select it, you will be able to identify the user and group assignments as well as test the single sign-on. Note that the testing is based on the premise that your current account has permissions to sign into the GitHub Enterprise Cloud Organization based on the user or a group assignment. On the GitHub Enterprise Cloud Organization page, select Users and Groups. And check the membership of the group listed there. Next, review the single sign-on page. Note that this includes the single sign-on settings for Security Assertion Markup Language, or SAML-based authentication, which is used with Azure AD as the identity provider. Test is available directly from the same page. Selecting Test Sign-In will open another tab in the same browser window, redirecting you to the page from which you simply select Continue to access the target GitHub organization. Before taking this step, it is highly recommended to download recovery codes and save them in a secure location. This allows access to the GitHub organization in case Azure AD authentication is temporarily unavailable. On the GitHub side, review the Enterprise Security settings. Note that you have the option from here to enforce two-factor authentication for everyone in your organization. You can also verify here that SAML authentication is enabled on the GitHub Enterprise Cloud Organization side. You can also enforce SAML SSO authentication for the Contoso organization. Note also that GitHub offers other security enhancements, such as IP Allow List, which limits access based on the IP addresses from which authentication requests are originating. As part of the proposed solution, Contoso will rely on GitHub code spaces for both individual and shared development projects. These pre-built development environments minimize maintenance overhead since they are automatically configured in an optimal manner with required security scanning extensions. Let's review how this approach works. You can access workspaces directly from the GitHub interface once you authenticate to your organization. The Code Spaces link is featured prominently at the top of every page. Once you select it, you'll be presented with the listing of most commonly used Quick Start templates that serve as the basis for provisioning the development environment. Choose React, as this reflects the preferred JavaScript-based programming approach used by Contoso developers. Selecting the template will automatically trigger provisioning the Code Spaces environment. Including a development server, compile the sample code, and open a browser window displaying the running application. As you can observe, Code Spaces provides a browser-based interface of Visual Studio Code, eliminating the need for a dedicated hardware. Contoso should leverage a number of security-focused features that are part of the GitHub Advanced Security offering, including vulnerability reporting, dependency graph, and Dependabot. These settings are controlled on the enterprise level, but can be individually enabled or disabled within individual organizations. It is also possible to enable them automatically on each newly created repository. Let's review this configuration for Contoso's GitHub Enterprise Cloud. On the Organizations page, navigate to the Security section and select Code Security and Analysis. From there, you can enable or disable the option to allow code security and analysis-related features. As you can observe, Dependabot functionality includes support for Dependabot alerts and security updates. Dependabot alerts generate alerts for vulnerabilities that affect your dependencies and manually generate Dependabot pull requests to resolve these vulnerabilities. Dependabot security updates allow Dependabot to open pull requests automatically to resolve Dependabot alerts. You also have the option to enable secret scanning, which results in alerts on GitHub for detected secrets, keys, or other tokens. Contoso developers should use Dependabot to ensure that their repositories are automatically updated to the latest releases of the packages and applications their applications depend on. Dependabot version updates are controlled by the dependabot.yml configuration file in each repository's .github directory. When the file is added or updated, Dependabot checks for outdated dependencies and, if they exist, automatically raises pull requests to have them updated. The file designates package managers for dependency updates along with the location of the package manifest files and frequency with which of checks should be performed. To ensure that Dependabot version updates are enabled and to review the content of the dependabot.yml file, navigate to the page of an individual repo. Display its settings page. And on the settings page, select Code Security and Analysis in the Security section. In the list of Code Security and Analysis configuration options, you will find the Dependabot version update entry. If you select Enable, you will be presented with the current version of the dependabot.yml file, which you can update and, depending on your branching strategy, commit directly into the main branch or submit for a review via pull request using a new branch. Once the Dependabot functionality is enabled in a GitHub repo, Contoso should see auto-generated pull requests that address dependency-based vulnerabilities. Let's review this functionality. On the repository page, select the Pull Requests tab. This will reveal the listing of existing pull requests. In your case, all of them have been generated by Dependabot, as you can easily determine based on the pull request details. Contoso should leverage Microsoft Defender for Containers, which offers vulnerability assessment and management tools for images stored in Azure Container Registry and Amazon Web Services Elastic Container Registry. Defender for Containers provides details for each vulnerability detected, including its security classification and remediation guidance. Let's examine how this works with the repo populated with the current version of a containerized Contoso line of business React app that is part of the pilot GitHub-based Continuous Integration and Continuous Delivery, or CI/CD workflow, targeting Azure App Service web app. To start, in the Azure portal, navigate to Azure Container Registry that stores the images used by the app. On the Container Registry page, select Microsoft Defender for Cloud Entry. Note that there is a high severity recommendation regarding vulnerabilities found in the Container Registry images. Selecting the entry will display detailed information regarding these vulnerabilities, including security check, category, the number of affected images, and availability of patches. To fix the discovered vulnerabilities, Contoso should consider taking advantage of the Dependabot functionality presented earlier. An alternative approach could involve the use of Azure Container Registry tasks. Another security enhancement that Contoso development teams should consider is ensuring that the main branches of their repositories are properly protected. The absence of such protection is automatically detected by GitHub once you navigate to the GitHub page of an individual repository. The interface also guides you through the process of enabling different types of branch protection measures. To start, the developer should require pull requests before merging, which ensures that all commits are made to a non-protected branch and submitted via a pull request before they can be merged into the current branch. To further secure their CI/CD workflows, they should also require status checks to pass before merging, conversation resolution before merging, signed commits, and successful deployment before merging. Now let's review a sample workflow that illustrates the CI/CD principles, which Contoso should follow in order to enhance security of their application's lifecycle. You have a GitHub repo hosting the code of a pilot application targeting an Azure web app for containers. The folder structure indicates that the deployment relies on the infrastructure as code approach in order to provision the target Azure resources by using Azure Resource Manager templates. The two templates present in the ARM templates folder handle provisioning of Azure Container Registry and an Azure web app for containers. The tests folder includes unit and functional tests for the application, which ensure that the application code is operational before its deployment to the production environment can be initiated. The .github workflows folder contains the YAML file, which contains the definition for the CI/CD workflow. As you can observe, the workflow is triggered automatically on push to the master branch. It is divided into 3 jobs. The first one handles the build process of the container image containing the sample application and its push to Azure Container Registry. The second one consists of actions that deploy the application to Azure Web App for containers. The third one is responsible for running functional tests. Next, let's review a sample workflow run. As you can observe, the run was successful. You can examine each of the 3 jobs by reviewing the run details. For each job, you can examine the sequence and outcome of individual actions. To conclude our overview, let's examine the functionality provided by the Azure API Management Service. Contoso should consider implementing API management as part of their transition to the cloud-based operational model. Azure API Management includes an API Gateway component, which serves as an entry point for all incoming requests and forwards them to respective backend services. The API Gateway acts as a facade to the backend services, allowing API providers to abstract API implementations and evolve backend architecture without impacting API consumers. It also enables consistent configuration of routing, security, throttling, caching, and observability. From the security standpoint, the gateway facilitates verification of API keys and other credentials, such as JSON Web Tokens, or JWTs, and certificates presented with requests, enforcement of usage quotas and rate limits that mitigate the risk of distributed denial of service, or DDoS attacks, and transforming requests and responses as specified in policy statements in order to prevent disclosure of sensitive data. To validate this functionality, start by navigating in the Azure portal to the API Management resource provisioned in the Contoso environment. On the API Management Services page, locate an API that is part of the pilot deployment. From there, examine the list of available APIs. To determine the available functionality, select one of them and review the configuration of the front-end, inbound processing, back-end, and outbound processing components of the API. For example, for inbound processing, you can add individual policies that allow us to implement such features as IP address filtering, which allows or blocks incoming requests based on the originating IP address. You can also set rate limit policies to control the number of requests reaching the backend service. Other options include mocking responses, setting query parameters, setting headers, or validating JWTs. Similar policies can be set for outbound processing. Next, examine the results of implementing Microsoft Intune to enforce configuration and compliance of Windows 10 and Windows 11 devices used by Contoso's remote users.